that founding insight, the core truth is that electrification in some form or another is going to transform aviation, just like we've seen in other modes of transportation. And back in 2015, there really weren't a whole lot of groups in the world openly talking about it.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
Today's episode is brought to you by our platinum sponsor, XTI Aerospace. They are powering the vertical economy, building a long-range VTOL, and you can find more at xtiaerospace.com. Now, please remember to like, comment, and share on this channel, and enjoy today's podcast. Welcome to Hangar X, and this is where innovators and leaders and people that are shaping and changing this revolution that's happening in aerospace come to get the latest information, make decisions, and I'm excited today to have you on, Kevin NOERTKER'S from Ampaire. Welcome to the podcast, first of all.
John, thanks. It's great to be here.
You have an aerospace engineering background, and what you've done when you started Ampaire is actually with this passion about hybrid electric, and we're going to be talking about this, but you set out with this mission and this passion to prove that hybrid electric is not only feasible, it's economical, but it also can impact and change regional aviation. And you started out with conventional takeoff versus vertical takeoff, because that's a big trend in the industry. We're going to be talking about that also. And I want to read a little bit about your bio. You got a killer bio, and I'm not that good where I can memorize it, but co-founder, CEO of Ampaire. You're leading the development of hybrid electric aircraft that's designed to cut operating costs and emissions for regional aviation. It's very important and growing. And before launching Ampaire, you worked on stealth technology at Northrop Grumman, and we were comparing notes. And I told Kevin I flew the F-14, which is the least stealthy plane that probably Northrop Grumman ever produced. We could hide if we were in a hangar underground. That's about it. You also helped solve some key hardware issues for NOAA's Joint Polar Satellite Systems, conducted planetary research at NASA's JPL, and you're a Caltech graduate, and now you're blending all this aerospace and engineering and business experience into something that's cleaner, more efficient. But so here's my first question, Kevin. With everything you've done in your career, solving hard problems, stealth, satellites, what had you move into co-found Ampaire and dedicate your life to hybrid electric technology and proving that this is actually not only viable, but commercially certifiable?
Yeah, I think, at the core of any of us who are in an industry or to generalize out even beyond aviation, entrepreneurs, builders, it begins with a core belief in what the future looks like. In a version of the future that you believe is inevitable, and that you know that you can make an impact on creating that future. And potentially, if you move faster than the rest, you might be able to build a category defining company. And for us, 10 years ago, this was on electrification. And it was the insight, that founding insight, the core truth is that electrification in some form or another is going to transform aviation, just like we've seen in other modes of transportation. And back in 2015, there really weren't a whole lot of groups in the world openly talking about it. This is before the Uber Elevate white paper. This is, early on, there were some NASA demonstrations. There were some companies, as you guys are aware, that were in the early stages of exploring the space, but really hadn't had that commercial boom. So it felt like it was in isolation. Like, why is nobody talking about this broadly when it seems so obvious? And I think that is the kind of the core insight that it begins with any innovation and entrepreneurial endeavor. And from there, it really came down to, so what? So what can we do meaningfully in this space? new aircraft designs, VTOL, supersonic, fully electric, hydrogen, hybrid. There are all these options and alternatives, even down to should it be, agricultural drones or carrying packages or people. And it was unpacking those insights and unpacking kind of the marketability, the timelines, the cost for execution, the profitability of various product segments that shaped Ampaire really into what it is today.
When you started amperage, electrification, right? Air. When you're thinking of electrification, did you guys start out with a thesis around hybrid electric? Or were you looking at, pure electrified, such as in batteries, like the eVTOL companies, and as we're seeing now, they're making a pivot toward hybrid because of the limitations of battery and the range, and they all want to get into the military space, and the military is like, well, having to charge it and with your range, no bueno. So, what would that you said that founding big idea, that founding thesis, was it around hybrid electric, or what led you to where you're at now?
Yeah, so the origin point, I like to think of it as our North Star vision for where this industry is headed, is probably one of the most audacious goals, far beyond what even most of the eVTOL folks are talking about. This was, and you can find remnants of this in the early materials for the company, and even today when you walk into our hangar, you're going to see a model of what we call the Tailwind. And the Tailwind was an aircraft design that originated as a fully electric, vertical takeoff and landing, supersonic business jet. And so at Centennial Airport, you guys are familiar with
fully
each
electric,
of these aspects.
supersonic.
That's right, full and VTOL.
Dang, that is shooting for the stars, because we have Boom out here.
That's
and
right.
They're working. One of their biggest challenges is the power plant. Mm-hmm. They could not find one that allows them to have the performance specs for the design that's going to allow make it the TCO, the operating costs, and what they need to do with passengers for the airlines work. So they're going to develop their own engine, and that's a whole nother level of complexity. But
it really is. And so you talk about founding vision and North Star. That was it for us. VTOL, supersonic, fully electric jets. And might as well run the airline too. And so that's where we began. But what our early job, like to call it early 2016 into really during 2016 timeframe, was to really unpack that North Star and say, what matters now? What is possible now? What are people willing to buy in the near term? And you start to ask questions like, does it have to be do you have to couple VTOL and supersonic? And those markets may not actually need to be coupled, because the supersonic, very long range, high speed, VTOL, convenience on where you take off and land from. At a certain stage, having these separate is fine. Similarly, when you start to decouple them, we realized that the biggest challenge at the core of this industry was around the propulsion. That to design a brand new airplane around propulsion that doesn't yet exist, well, we've seen those stories. We've seen companies try to design brand new airplanes around a moving target for their propulsion source, and that's a guaranteed requirement to redesign the plane at least once, if not multiple times, as the propulsion matures. And we figured what the first step is in this industry is to get the propulsion right, and then to design planes around it. And so we said, well, we'll get the fully electric propulsion correct first, and then we'll go design fully electric airplanes around it. And that propulsion needs a place to go. And so we said, let's go retrofit Cessna Caravans and Skymasters with a fully electric drive. And then, and this is like 2017 timeframe, fully electric drive on a Caravan, which the market loved. They loved the theory of it, but as we
remember when those headlines first came out, it was fascinating. I was following your story and your progress with a lot of interest at the time. I had a lot of doubts on how can you take something with the size and weight of a Caravan and have any real world performance, but that really wasn't the point at the time. The point was to prove, can this technology power an aircraft like that? Is that fair?
That it was fair. We did think that there was going to be a big market for fully electric caravans, but that at that point in the company, this was a launching point strategy just to, prove it out in a sufficient market to then go into new build planes. What we realized, though, is that the caravan market was an immense opportunity, but it was not viable fully electric, at least not with near-term technologies and near-term infrastructure. And this is where we turned the corner on hybrid electric propulsion. And specifically, as we were flying our Cessna Skymasters around, first flight in 2019, and then ultimately our deployment with Mokulele Airlines in Hawaii in 2020. That 2020 deployment in Hawaii was a major aha moment for the company.
Is that flying under a type certificate?
No, that was flying under a market survey. So
Okay.
experimental market survey category, airworthiness certificate, and running the EAS routes, but non-commercially.
Okay.
And so what we realized, so it took us about 18 months to build up that variant of the Skymaster, hybrid electric, push-pull configuration, one fully electric, one combustion engine. And during that 18 months, we were also working on, just with the infrastructure folks, to put a simple level 2 charger on the terminal side of the Kahului Airport. And with everybody aligned, from the operator and infrastructure folks through the power company and the politicians involved, everybody was waving like, let's go get this thing done. And yet we got the plane there before we could get the actual infrastructure installed. And what this told me is that even when everybody thinks it should be easy, the reality is charging infrastructure is going to be relatively slow to proliferate across the world, especially in some relatively poorly served markets with poor electrical grids. But
And I would
also
highlight that I think it's as or even more challenging in a developed urban environment.
quite possible.
I mean,
You're right. All the
we actually
stakeholders.
had Rex Alexander on. He said, to power, let's say, a 6-place vertiport would be the same power needs as 6,000 homes.
Yeah.
I mean, think about that. So is LA going to give an approval for a place for 6 eVTOLs to land and take off, or a new development after they rebuild from a wildfire?
Right. I know. So this is a critical bottleneck on the infrastructure side for fully electric. And that realization, plus I had infrastructure investors telling me, Kevin, I only need 2 things from you. I need you to tell me how much power and when. And I need that with certainty. How much power and when. This is about the rate of scaling and adoption over time. And that is actually a very hard question to answer for fully electric, because the rate of adoption is uncertain. There's so many uncertainties on timelines and specifics. And so the infrastructure investors who need 3 to 5 years just to get started before the infrastructure is available in major upgrades, they weren't willing to even touch it. And so these realizations led us to a decision in that 2020 timeframe coming out of the Hawaii demo that our launch product must be the type of hybrid that can self-charge, like an early day Toyota Prius that is infrastructure independent, maybe plug available and optional, but that if you're flying in rural Alaska, you don't need to worry about infrastructure. And that was a categorical shift in our company's priority set in the architecture that we were developing for the Caravan and for other airplanes. And subsequent to 2020 and 21, 22, and subsequent, you could see we aggressively moved on the Caravan, flew the first hybrid variant of that in 22, in November, and then have been upgrading every underlying component and piece of the supply chain, as well as moving on the regulatory approval on that engine as the launching point for, again, going back to the vision strategy, get the propulsion right, build a meaningful solution there that's broadly scalable across the industry. Retrofit Caravans, Twin Otters, Kodiaks, King Airs, and such. Take that and drop it for onboard power and for dual use applications. Big market opportunity there. And then earn our way into, by great aftermarket support, earn our way into the trust dynamic that establishes the winners of the industry. And if you were to look at any of the verticals in aviation, you've got 1 or 2 companies that dominate each vertical. and now's the opportunity to build that propulsion company that serves the breadth of the industry for the next 50 to 70 years. And so this is where it begins.
Yeah, and you guys have flown meaningful hours, real routes. What are some of the most significant milestones, in your opinion, you've hit recently?
Yeah, so really excited about the some of the tests that we've done to show interoperability with the needs of real operators. So we took one of the Skymasters and we deployed up to Alaska. This was in partnership with the DOE. Met with some of the politicians and energy and aviation folks up there, but really this was about overcoming the rugged realities of the real world. I mean, we were stuck in Whitehorse, an airport up in the Yukon, as thunderstorms were rolling through and literally like pouring water out of the wings of this Skymaster. When we go back and validating, okay, we've been through a torrential downpour. How's this electrified plane? How are the batteries holding up? And working through that. So the real world deployments are some of the most exciting and meaningful milestones that we see. So whether it's Hawaii or in the UK,
well, if you were
or
to
up
fly
to
in Alaska in the winter, because it's bitter
in the winter, yeah.
I've been up there to Fairbanks, to the Air Force
That's
base
where we landed,
a number of times. But how does that affect the performance, the battery?
So we were there in August. So, but let me tell you, the folks in Fairbanks loved reminding me that when it's -40, things start to break. And I'm looking for the university.
Also not unique to hybrid electric.
No, not at all, right? And
Yeah.
and so the university up there has a whole like electric vehicle cold weather testing and technology development branch, and so we're working with our eyes wide open on those requirements. We haven't put our system through that extreme of an environmental test yet. The reality is that our hybrid engines, our hybrid electric propulsion systems have relatively small battery packs, have a relatively benign like thermal challenges. It's relative to if you were fully electric, being cold soaked. Ours is a pretty approachable challenge, and things like heat blankets and things or significant range degradation because of cold weather. As a hybrid, your cruise range is governed by the fuel you carry, not by the electric battery. So what we really have to look at is what is the power draw and the limiting factor within the battery for your takeoff and climb cycle for that electric boost in the Caravan specifically. And what we've found is that we were able to meet all those requirements just fine.
Yeah, and could you share some, because I think it'd be really good for people to understand. If you guys go to Ampaire, AMPAIRE.com, and you can look under portfolio, it's the H570 is the engine.
That's right.
That you're talking about now, and it's a really unique architecture. It's really designed to replace like a PT6, right?
Correct.
That kind of output, that kind of power. I'm just looking here. It has peak is 764 shaft horsepower, and that's when the electric motor is kicking in extra torque. But could you just talk about maybe at a high level, what is the architecture of that engine? What's the gas part? Is it running a generator and it's the electricity driving the prop? Could you just share what's the concept and the engineering behind what you've created?
Sure. So there are a wide variety of architectures for hybrids that will eventually hit market. Series hybrid, parallel hybrid, massively distributed hybrid for ultra STOL aircraft types. What we picked was very specifically the type of hybrid that achieved minimized barriers to entry and maximized fuel savings in a single or in a conventional integration into an aircraft.
And your fuel savings compared to a PT6 are 50 to 70%, depending on some of the operating conditions, right?
That's right. Yeah. So average 50% fuel savings compared to that PT6 in the Caravan. And during takeoff and climb cycle, you're at 70%. So let me describe how the system works and why it actually achieves that level of efficiency. So of the types of hybrids, we're using a type that we've coined as a integrated parallel hybrid. So parallel hybrids are where you're getting your mechanical output from both the combustion portion and the electric portion. And these two are then coupled together to the output shaft. And so think of your combustion engine with an electric machine coupled to its output that then coupled to the propeller in the airplane. And now what you can do is you can run that combustion engine and leave the electric idling. You can add torque to that system with the electric engine, the electric portion, or you can actually remove torque from the system to recharge the batteries with that electric machine. And so this is the architecture that we use, and how we use it actually originates with why and how an airplane is flown. And these specific types of planes are generally flown. You've got two power requirements, two power settings: really high power during takeoff and climb, and relatively modest power during cruise. Now, when you only have one engine, a thermal engine, a combustion engine, you've built that engine to hit your peak power requirement. You're kind of accepting whatever efficiency it has at the other points. But a hybrid engine allows you to optimize for more than one power setting. And that's exactly what we do on our system. We optimize for both the cruise setting and for the peak power during takeoff and climb. And the way we do that in this architecture,
from a design perspective, is that typically a trade-off between peak power or cruise power?
Yes, it's a trade-off amongst quite a few limitations and competing goals. So you're trading off weight and balance. So what's the size of battery pack that you have, which then limits how much power you have for that takeoff and climb. There are other hybrid architectures where you want to do fully electric takeoff and fully electric cruise. So you're sizing the motors differently, maybe using that combustion engine as just a fallback, independent parallel architecture or a gen set to recharge the batteries. So these trade-offs are about the efficiency, about the integration, about the weight capacity. And in retrofits, how the weight limits the payload capacity of the vehicle. And ultimately, as a commercial plane, the payload is everything. And then all of this ties in with the range of the aircraft and how far you're able to fly that mission. And then, of course, the fuel burn along with it. So what we're able to do in this particular architecture is size that combustion engine for very fuel-efficient cruise. If you used the combustion engine for takeoff, and no electric boost, you could clear a 50-foot obstacle, but you wouldn't really get the performance that people want on a day-to-day basis. So what we do is that's just called the marginal power, cruise, and minimum safety requirement from your combustion engine. And then you add a power boost on top of that in this architecture with your electric system. And that power boost really is used mostly during your takeoff and climb cycle. So call it 5-10 minutes, depending on what altitude you're going to, at relatively high power, but adding power on top of the combustion engine. This architecture, what it enables us to do by optimizing the type of engine and the power level of that engine that's for cruise, we're able to get 45+% fuel savings just on that engine alone, because it's the right engine for cruise, not upsized for takeoff. And then when we're running the takeoff cycle, because we're getting all that extra boost power with the electric system, I'm not burning more fuel to get it. So I'm actually increasing my fuel savings in that relative period of flight up to 70-75%. And then that nets for our customers out to usually around 50% fuel savings. While with the coupled system, we're also able to recharge the batteries in flight. So you're landing at your next airport, ready to go for your next takeoff cycle, no charging time needed. And that's really
is your fuel reduction in cruise because you optimize for cruise, or is the electric system contributing to that and in cruise contributing to that fuel, that reduced cost?
In this particular architecture of a hybrid, you're cruising on purely combustion.
Okay.
And so it's about the fact that you were able to put a combustion engine in the plane that was itself optimized for the cruise power setting.
Same true airspeed as the turbo
capable of it.
Okay.
Yeah. I mean, most of our customers choose to operate the plane at basically the most fuel efficient.
Okay.
So this is like 150, 155 knots. And we can hit those speeds. Chances are people will optimize because of our specific fuel efficient point, probably 5 knots slower, but same ballpark.
Okay. That's awesome. You know, some exciting things with the FAA, getting your G1, marching through this process, certifying this. What is the Eco Caravan still on track to get certified next year?
So the Caravan is under two different STCs or two different certification programs.
Okay.
We have the engine, right, the AMP drive unit, which needs to go get its approval, and also the STC to put that into the Caravan as a retrofit, an engine retrofit, and making phenomenal progress on that. We are, to our knowledge, the only company in the certification process with the FAA on a hybrid electric engine. That's the formal process. And we just got that G1, the certification bases, and are now working diligently on our means of compliance and special conditions, which would be the G2. Hope that comes out. FAA shutdown, we'll see exactly what the timing looks like here, but comes out probably early next year. We've got about 18 months of really focused work in front of us in order to go get the STC on the Caravan. That 18 months, based on our current timelines, look like mid-2027, practically. Okay. And I think that's
engine next year, and then the STC the year after. That's kind of the.
Yeah, I mean they're really running in parallel with each other, so I don't expect to have a engine STC finalized too much ahead of the overall. Just because a lot of the testing will overlap. What's amazing about it is, though, that when we get the engine certification, that will be applicable into a variety of aircraft types, even beyond the Caravan. And so I expect that once we have the Caravan cert, there are variants of the Caravan we're going to have to go after, different power levels, and then there are all these other turboprop planes in the same category, using categorically similar PT6s, and those will be the first that we go after subsequent to the propulsion here.
Okay, so that's a question for you, Kevin. When you say categorically similar, is kind of the roadmap at Ampaire to say, okay, this is our market, this is where the opportunity is to basically be this replacement for airplanes like the Caravan, or is it and/or take this architecture, scale it down? Because, you know, one of the things you hear about in both the commercial drone and the military is, hey, I want something that can go 500 miles and can carry 500 pounds, or 1,000 miles and carry 1,000 pounds. And, you know, that could be fit into something that's VTOL or, you know, STOL, short takeoff. The hybrid electric power plants are required to enable some of those. Is that something you're looking at, or right now you're just staying laser focused on your wheelhouse? Give us a little insight into your strategy.
Yeah, so back to the vision, the type of company and what I see the opportunity in the spaces. I think electrification is going to touch every part of this industry, from small general aviation planes through mid-class turboprops, through drones and defense, all the way up to regional jets and you know, your narrow and large bodies.
VTOL supersonic aircraft someday.
Maybe someday.
I mean, the galaxy.
Right? Like heck, I've literally had people asking me if these engines work in space, and so like
the electric part does, but
over the horizon
Yep.
type opportunities here. I believe in that future. Now, there's a lot of question about timing for any of those things and practicality of, like, does it matter? Is it necessary? But what I do know is that these systems, these amp drives that we're building for the Caravan, we're able to up power, down power them very efficiently in other PT6 class planes. We're able to take the exact same electrification system, so the power electronics, motor architecture, battery architecture, and upsize, downsize that around different class aviation combustion engines. So easily dropping into a general aviation class or a onboard gen set for a series hybrid distributed electric propulsion, like you mentioned on the drone and VTOL space.
Just to clarify, we compare this to PT6, but the conventional side of this is piston or turbine?
The conventional side of this specific airplane is a compression ignition engine, which has pistons and runs on Jet A.
Okay. So like almost like a diesel concept.
That's right. Diesel cycle engine is another word for compression ignition.
Yep. Like, I look at, I wanted to buy a DA62 with the diesel engine.
Precisely.
And I got to tell you that it's so attractive. The power, the reliability, the fuel burn, the FADEC.
Exactly.
What you can do with an engine like that as an operator and a maintainer is phenomenal.
It really is. And yet the challenge that compression ignition engines, diesel engines, have had in aviation is that they're a bit heavier than your turbine equivalents. And so you really have to, historically, would have had to design a brand new airplane to take that integration, just like Diamond has. And that makes it difficult for the compression and ignition engine manufacturers to retrofit into the market or move broadly, because simply it's a hard sell from a weight to power ratio standpoint. And yet we're able to overcome that by electrifying and building hybrid variants of these systems that give them a PT6 equivalent performance at compression engine level fuel burn, which is a really phenomenal benefit. And in addition, when we talk about safety, so imagine you're taking off from an airport and shutting off an engine and trying to get back to that 1,000-foot landing strip nearby. What if you had an electric boost that can actually give you power to power through that moment where your combustion engine had an issue? Or vice versa, if the electric had an issue, you can power through with your combustion, no problem. This is a level of layered resiliency, graceful degradation for the system that simply wasn't possible with traditional single type engines, but in a hybrid type engine where you have multiple sources. Now you have this, especially for the general aviation population, this great safety benefit that we will be able to bring to them.
Well, I'm a huge fan of that. Is, the military training is from day one. You have to be prepared that at any moment the instructor is just going to chop the power to zero and say, you just lost your engine. What's next? It doesn't matter what you're flying, from a small little turboprop up to a fighter. And the fact that if I lost my engine and I can get to a good place, or I need a little bit more range, or I need to come in and flare, now I have that power that I can instantly have access to and feather it in or extend my range and just have that it extends the safety margin. I don't need to have a parachute on the airplane. I don't need to have a fly home button. And I think that's a huge advantage. And I'm guessing also based on the need or the safety margins or the mission set, I could actually work with you. Let's say that I was going to put your power plant into my plane and size the battery. I might want to have a little bit extra. There could be a trade-off to that. But these are the things that if I'm an OEM, I could work with you to size a couple different. Once you get this certified, I'm guessing expanding or contracting the electric side is probably fairly straightforward at that point.
Exactly. Yeah, you can change the power level of an electric machine, the motor, relatively easily by changing its physical dimensions. And using, by and large, the same types of power electronics to operate it. So it's a very easy modification there. And as you mentioned, the energy storage systems, the battery packs, you can increase the number of modules or decrease the number of modules relatively easily. Like, it'll probably need a new STC, but it's a relatively easy modification to really tailor to the operation. So when I'm, even within the caravan market, when I'm talking to skydive folks, they have a slightly different need and use case than the operating than the operating case for a cargo operator, right? And yet I'll use the Caravan. Now we can actually tailor solutions more readily to those different market segments without having to have a whole re-engineering of a combustion engine.
Well, I love that. Well, I'm excited about what's next for you guys. So if you've been listening, please subscribe, like, share to our channel here, to YouTube. Tell a friend about this. There's so many exciting things happening. The work you and your whole team are doing at Ampaire. We were talking, I think, before we hit record that, you're going to be flying that Caravan across the country. So everybody stay tuned when Kevin, when you and your co-pilot come here and land at Centennial, we're going to be out there with the cameras rolling and do a whole thing, maybe even go up flying with you, because that would be really fun to share with our large audience. And, as we come in to land the plane, for you personally, Kevin, CEO, co-founder, let's just say we were getting together a year from now, right? Next fall, right before Thanksgiving. What's one thing that you just love to be sharing and celebrating that you and the team accomplished over the next 12 months?
We're at this inflection point in the company right now where we're about to launch some pretty broad scale demonstration programs with some pretty notable customers. And by 1 year from now, I'm looking forward to being able to share and be very grateful for the fact that not only have we delivered on the opportunity to start to run those pilot projects and operations, but that the world will have this dramatically increased exposure to really what the realm of the possible is here in this advanced aviation space, that we will have been able to land and touch so many different communities with such visible and easy to understand benefits without a whole lot of the raising of the eyebrows questions that many of the advanced air mobility and eVTOL industry receive. This is just a, better cost, better operating cost, ROI on day one if you're buying it instead of a combustion engine, better for the environment solution that at the end of the day is also safer for the people on board. Like that's just great. And I'm looking forward to when more of the world has a chance not just to hear it, but to experience it directly.
Man, that's exciting. Well, Kevin, thanks for coming on. You guys are welcome to come back anytime. And, it'd be a good follow-up is even do a more technical deep dive. I think there's a lot of people out there that really want to understand your architecture. There's a lot of other hybrid companies that are coming out with some other architectures that I know of. And I think just educating the industry on this capability, and I think the awareness is going up, especially as we're hearing about some of the programs at AFWorks and DARPA and some of the other large commercial companies that are moving in hybrid. But this is going to impact everybody. Centennial, commercial airplanes all over the place. And fuel costs are going to go up. It's, $8 a gallon. If I can cut that down to $4, that really changes my TCO, my cost per seat mile, the cost to get last mile logistics out from a place like this out to maybe a more rural area. So excited about what this facilitates as aviation continues to go to that next level. So
amazing. Well, I'm looking forward to building that future too.
All right. Keep knocking them alive, Kevin.
John, thanks for having me.